Hi everyone, this is Barry Coombs from ComputerWorld and DefineTomorrow.co.uk. I'm joined today by Jason Southern of NVIDIA. Jason, would you like to introduce yourself?
Hi everyone, I'm Jason Southern, Senior Solutions Architect for NVIDIA Grid. I'm based in EMEA, but tend to work across the globe.
Fantastic. So I've known Jason for quite some time. We generally bump into each other around Bri Forum time. Jason, I think you've been connected with that community now for some time.
Yeah, I've been hovering around various technical communities like that. I think I've been in virtualization, well, for too many years I care to think of, but it's coming up to 18, 19 years now, even before desktop virtualization had a name.
Really? I don't remember that. You must be a bit older than me.
It's WinFrame, oh, probably scarily older than you. Yeah, all the way back to the WinFrame days in the late 90s.
Okay, fantastic. So from our perspective, I think what unites us now is kind of a passion around technology, around end user computing, enabling users, whether that is on a physical workstation or more recently virtual and VDI. And I think NVIDIA's story has grown over the years and has now been able to be incorporated in virtual desktops, as well as that kind of ingrained knowledge that we have maybe from our childhood with lots of people in the gaming industry. Some people then grow up with NVIDIA in the more professional industries, sort of the creative industries, gaming and things like that. But now we're finding NVIDIA starting to get involved in a lot more tranches of life, which for me, I had the opportunity recently to head over to NVIDIA's headquarters on a program called Grid Days that Jason was very kindly managed to hook me up with. So Jason, from your side, where is your focus inside NVIDIA itself?
So my focus is on professional graphics in virtual environments. So it really is focused around desktop virtualization, taking GPUs and virtualizing them and making them available to all. When we talk about desktop virtualization, that does also include things like RDSH. So anything that's on a shared and hosted platform, as well as a single instance server, a virtual desktop as well. That's where the technology has changed over the years as well, because previously, or about 3 years ago before Grid was launched, you could put a GPU into a virtual environment, but it was on a one-to-one basis. So the scalability and the density wasn't really very good. You had one card, one server, one user on there that could use a GPU. Anybody else that needed it had to be on a separate server with another card in there. And that's really where Grid came into play, is to the ability to take a single card, have multiple GPUs on it, but then also virtualize that GPU. So that's the area that I focus on. But we also, the way that NVIDIA works is that although you might have a specialist, a vertical where you specialize, in my case virtualization, you also get involved in lots of other areas of the technology as well, because GPUs, as you discovered at Grid Days, cover a lot of areas beyond just graphics.
That's it. And certainly for me, that was an amazing part of being lucky enough to head over to California, sort of into Silicon Valley, where your headquarters are, sort of taking up many of the buildings over there, and seeing the massive new construction site for your new headquarters being built. It was how ingrained into our life NVIDIA is becoming, more so than just the gaming. And we were lucky enough to see some of the games in development there, some of the developers that had been working on some of the biggest games with the likes of Sony and Microsoft, to obviously the technology that I was there to see, the virtualization technology that we're going to talk about a little bit more, but then kind of also going into the future a little bit. And I learned about, one was the automotive industry and the intelligence behind autonomous driving. We were able to see a demonstration of NVIDIA technology driving a car under its own power around a underground car park, choosing a space of its own accord and then reversing into it. And you kind of think, well, so what's NVIDIA got to do with that? Is it displaying some pretty graphics on the screen whilst it does it? And once you start to think about it, it's all about visualization. If there's anything where we need to be taking in some form of imagery and doing some form of processing to it, that is where the graphics processor is so well designed to handle those workloads. Why is a GPU more inclined to be able to handle those workloads than a CPU workload?
Well, if you think about what you're doing when you're driving a car, or when you're doing any task like that, is you're doing lots of things all at the same time. You're not just doing a single process, although that process is driving a car. you're looking at the road around you, you're looking at the speed you're traveling at, you're looking at what's in near proximity and taking all of this information in and then making a decision based on it. And the GPU is built to undertake lots and lots of parallel tasks instantaneously. So if you can do hundreds and thousands of tasks all at the same time, every single millisecond, then you can make very rapid decisions about where the car should be. Should it start applying the brakes? Should it turn? Should it continue on the path it's in? And it can take sensor data from around the vehicle and feed that in centrally. And this is where the technologies that we work on come into play. We build a platform called Drive PX, and that platform has development kits available to it for it. So any automotive manufacturer can go and take this and take the sensor data that they have in their vehicle already and apply it in, and then use that to develop self-driving cars, or even simply self-aware and automatically sensing a danger situation and applying the brakes. So lots of things, doing decisions and thinking about things all at once and then feeding into making a decision. And that's what the GPUs are very, very good at.
And it completely kind of overwhelmed me as to the level of involvement where the GPU actually could have a use case in everyday life. And that was one example. The other was something as simple as the speedo and what the speedo needed to be able to do.
That's right,
digital speedo. Effectively, you just think, well, it's just an image on the screen. But wait a minute, what happens when the sunlight changes? How does it have to reflect and change? And it needs to always be visible no matter what the situations that have been placed upon that. So then even some more life-changing scenarios. I mean, a big part of the 2 days over there was about deep learning. And this wasn't even a concept I'd ever really heard about. I've certainly never done up a reading about it, and the gentleman that did the presentation for me really made me feel like I hardly know anything. His level of knowledge, the kind of background that he's got, and the level of intelligence that is being put into the platform. The demonstration we saw two of them. One was effectively 1 million images being they were collected off the internet. They would seem to have no relation as a number of images being fed into a background process, and then using the power in the GPU to effectively sort those images into categories. And true enough, we were then able to go and click through a sample of this data that it had sorted. And of course we could do that with a processor, but what they were showing is that we could do it in a matter of days rather than weeks or months, sorting that same amount of data. And we zoomed into one corner, and factually enough, they were all aeroplanes. But not only were they aeroplanes, they were aeroplanes that were on the ground. And then we went to another area, and they were aeroplanes that happened to be in the sky. And clearly there were one or two that actually, that was an aeroplane that was in the sky, but the sky was too grey and it hadn't detected it was fine. And you could then tell it, no, actually, learn, this isn't what I was looking for. But then that's all well and good, and you can see a use for maybe people like Facebook or Google or, I don't know, Getty Images, people that are managing a large amount of images. But what use can that have in real life? And that's when we started looking at the medical use cases.
Yeah.
And for me, I think we were grabbing a large sample of images, feeding them into this engine, and it was able to detect minute changes in people's eyes that actually were highlighting where eye disease is likely to be within that subset of people. So instead of going out there and saying, right, we're going to go and examine 100,000 people and see who is most likely to be having eye disease, we were able to bring that straight down to tens or hundreds of people and go, these are the most likely people based upon what we're seeing in this image. And once you start thinking about that, how else could we be applying the technology?
And that's where NVIDIA is one of those places where you can walk around the campus, turn a corner and get your mind blown every single day, because people are looking at the technology not just as to how is it being used today, but how do we use it tomorrow? And it's why we invest so much time and effort into the software platform, so that people can develop these technologies, and we have outreach programs to developers. And yes, there are probably people that will look at this technology today and go, I have a fantastic idea for that nobody has ever thought of before. Medical use cases is a fantastic one, where we're identifying potential cancer risk. You think about how our doctors go about looking at things today. They look at MRI scans, they look at X-ray images, and they have to make a conscious decision about which is one of these a tumor or is it not. If you can have a system which can automatically do that and can take any emotion out of the situation and just simply make a decision of benign, 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 tumorous, malignant. And you can very quickly help people early on instead of waiting sometimes until it becomes obvious to the human eye. This is the thing that we're learning, is that now we're getting to the point where machines are being much more accurate than the human. And it's only in the last 12 to 18 months that this has happened. Before then, the human was always just that bit more accurate, but now we're getting ahead. And it's all about, really, if you think about it, it's about taking the amount of time it takes to do a task out. We've seen it in the construction industry as well, where they use similar kinds of systems, not for image recognition, but for very rapidly scaling out models. Build a model in a virtual environment. Does it work? No. What if I move this bit around and then rebuild that section of the wall or that floor? If I move these pillars around, and people are building software that will automatically go through and do this without any human interaction at all, and then come back and say, this is the way you should build the building. And then the next time they run the software, it comes out with a completely different result because of the decision path that it's made on the way through. And that's what's fascinating about it, is that we're actually letting machines make the decision as to what the best way forward is. For some people, that's quite scary.
It's trying to imagine the way that the technology can be used, that it's not only driving your car, but it's able to be making decisions about your life and your health and things like that.
Yeah.
It certainly does. And you connect that to the sensors that could be used in the future around your life to collect this information. That is very scary as to who's got this information, how do I use this information? But equally, if you do buy into it, you can see the advantages that it could offer for your life, for your existence, and for your ease of life, I suppose, at the other day, your quality of life.
And that's it. It's about how do you use the data, how do you use the information around there, and information. There are huge swathes of information around and about individuals. There are store loyalty cards which give you points in return for basically telling them every single bit of information about your life. And lifestyles, all the way through to all of the traffic sensors and things that we just aren't even aware of that are out there on a day-to-day basis. And how that information is used and brought together, now machine learning becomes a part of that, but yes, there has to be some control and some respect for people's privacy in that as well. And the medical industry have got that really well locked down. They know how to anonymize data very, very well. And I think a lot of other industries just have to learn from that.
Definitely, we need to get that protection in there. So if we come to some of the other elements on there, we've obviously got, if we go very briefly to the gaming, because I think it kind of segues nicely into where we want to go in enterprise graphics.
And it's what everybody knows NVIDIA for as well, as gaming.
The amount of people with tattoos with NVIDIA on, I didn't realise. It seems to be a common thing at NVIDIA that have you got an NVIDIA tattoo. But from that perspective, obviously we know the involvement that NVIDIA have had with graphics cards over the years, and fantastic consoles and PCs, probably where they're more known for. But the work that you guys are doing with the manufacturers to make them realise the capabilities of the graphics cards now is quite amazing. But for me, the bit that really set home where the whole industry is going, gaming and professional industry, is by being able to use the power of the grid card in the back end to then actually play the game remotely. So all of a sudden I don't need a PS4 there. I've got your console. Is it the Stealth? Is that what?
So the Shield.
Shield, that's it. Shield console. I've got that sat under my television, and it's no bigger than, I don't know, an Apple TV or something like that. And I'm playing a game that is actually running out of a European or American data center, yet the graphics on it, to me, and I'm not really a gamer, so I'm not looking at the micropixels. I'm sure someone will put me to shame. But certainly the power of what I'm able to get there, the immersiveness of that game, I'm able to achieve that without a £400 console, without buying a £40 game. I'm paying a subscription, and all of that intelligence, all that advantage, all of the upgrades is all going on in someone else's data center.
Absolutely. Somebody else is worrying that your hardware is up to speed and available and able to deliver it. Yeah, so that technology is called GeForce Now.
Okay.
Or I should say that product is called GeForce Now, and the technology that underpins it is Grid.
Yeah.
So effectively the same technology that the enterprise organizations that you and I work with regularly can implement into their environments. But yeah, gaming is where we learn a lot of lessons about user interaction and about user experience. So a gamer is going to expect that anytime they have an input into their device, whether it be through the keyboard, whether it be through the mouse, whether it be through a controller, it has to appear on screen instantaneously, or to them instantaneously. And this is one of the reasons why they push for really high frame rates in gaming, where gamers become obsessed with very, very high frame rates. And to some extent we do as well as a result, because it reduces lag and it also reduces motion blur. Now, if we can learn those things from gaming and be able to deliver a good, if not a great user experience and a gaming experience from a data center that sits in either Santa Clara or Amsterdam to you in the southwest of England, and you don't care where it's running from, you've just got your internet connection and a box that's, sometimes somewhere between an Apple TV and a Kindle, just sat there running. You pick the controller up, you choose which game you want to play, and in 30 seconds you're in and playing.
That's it.
And then we can bring that learning to all of the enterprise space and really step it up a level again there.
And I think for me now, we're getting on to the enterprise factor, and the reason for me why I attended Grid Days, and I think why NVIDIA put Grid Days on, as much as it was fantastic to see all this other stuff and understand a little bit more about NVIDIA. At the end of the day, we're all kind of there for a common goal, and this is kind of graphics in the enterprise, specifically the Grid products, specifically around virtualization. NVIDIA have a recognition that they want to work with the community a lot more. They're looking forward to create a community program, and most importantly, they want the feedback from the community. And whilst there were only 12 of us, I think, in the room, we were using the NVIDIA forums as a place to be able to set our agenda. These are what the people in your community are saying. This is what you should be listening to. And that was really important for me, and it was split up into two elements. One is the elements that the people that did attend have been able to speak about, that we're going to speak about today, and the other was the NDA material, the material where we were being used as a sounding board to understand some of the challenges you've had and where you want to go into the future. And I think we can look forward into slightly later in 2016, but hopefully not too long, to see what those announcements are going to be, and then see what the result of the community is. But I think from our perspective, the people that have been lucky enough to see that, it's really clear that NVIDIA do want to listen to the community feedback.
Absolutely. Community feedback to us is hugely important. We've been doing this for a long time in the gaming space. Again, we take feedback, and we have a core group of gamers that provide us with feedback on hardware, on how the drivers affect their gameplay, and all sorts of other things. And we regularly meet with them, bring them into the organization and put them through pretty much what you've been through recently. Is let's show them everything else that we do as well as gaming, and then talk about gaming specifically to them, because those gamers today could be the engineers of tomorrow. They could be driving those or building those self-driving cars. We just don't know. They could be the physician that's using the software. We just don't know where they're going to end up, or they could remain professional gamers forevermore. So taking what we have there and then bringing it into a more enterprise-focused group is what we're trying to achieve. Now, where we're going about that is we're starting off with Grid first. Although we have the high-performance compute side of things, which is also a technology space that we sit in, and where machine and deep learning sit. We saw it as, because Grid is quite a new product to the market, it was a good opportunity to start building a community right at the beginning as the product was coming on. And yes, taking feedback from yourselves and from other people out there is hugely important, because we are actually, although NVIDIA is a 10,000 employee organization, Grid is only a small part of that, and we only have a small number of field-facing individuals. Probably out of those 10,000, 8,000 of those are engineers and designers that are building the next generation of product. It's the rest of us that come out and see you guys. So we're a really narrow channel to obtain feedback and push it back into the organization. So building a community is really important. The forums are one aspect of it, and it's a place where anybody can come along and join up and provide their feedback and ask questions openly. Where we can answer, we will. Of course, there's always material that we can't share publicly, and it has to be under NDA, or we're just not at the point where we can tell them that. And then, but that's where the grid days that you experienced come in. So this is an opportunity for us to take a group of a subset of the community, bring you to Santa Clara, bring you to our head office for a few days, show you what we're doing, show you where we're going next with grid, and then get your feedback on it. Tell us where we've gone wrong. Tell us what we're missing, and tell us where you think we could benefit the rest of the enterprise space by going in the future. And hopefully that's what you experienced from those few days there.
Definitely, and for me that was kind of ingrained throughout the days. As much as there was some fantastic demonstrations, I was able to see some things that I wouldn't have had the chance to unless I'd gone out there. It was clear by the amount of people, and there was 12 of us in the room, there was easily 12 or more NVIDIA people in the room at the same time. This wasn't a marketing exercise. We weren't sat there with a couple of people and then whining and dining us and saying, can you go away and talk about the technology? There was people there from all levels of engineering actually wanting to know what mattered to us, what mattered to our customers, what mattered to the community members, how were we using the products, how would we like to use the products, let's go there. What is the cost of the product, how are they licensed, and how are we managing and maintaining and monitoring those products? And as I say, there's a lot of elements there that we can't get into at the moment because of the NDA, and we will do when we can. But I think it's important that maybe for those listening that aren't overly familiar with the NVIDIA product suite, that we do take some time to understand what does it look like in virtualization today.
Absolutely, yeah, let's touch on that. But one thing, just to finish off what you were saying there, is I think it's important to know that this interest in taking feedback comes from the CEO down. So our CEO, Jason Huang, is one of the founders of the company. So he's an engineer, he's an engineering graduate, and every time that I've been in a meeting with him, he's not been interested in what's going well. He wants to know what's broken.
Yeah.
What does he need to give his attention to and his weight to fix and resolve? Because if things are working fine, things are working fine. It's what's broken, what do we need to fix? And by taking feedback from everybody in the community and everybody out in the wider field, we can help provide that information back to Jensen. So by helping you, we help ourselves, we help the boss understand what he needs to do and what direction we should be going in. And sometimes he will change direction overnight just because it's what we have to do the right thing for the customer and do the right thing for the product's direction.
Definitely. And that did come through with all the people that we were speaking to there.
Good.
So I think the next piece we need to get onto, as I mentioned there, was kind of the bit that we kind of are working with on a daily basis. In a VDI environment, where is NVIDIA's piece of the puzzle? Do we need to be putting GPUs into all of our desktops? Is it the fact that you're a CAD designer, so of course we need NVIDIA technology into it? I think it's quite a complex area that we need to consider. With VDI, we're generally trying to bring the cost down as low as possible. So to us be suggesting that you do need a GPU in some form, only not just at the top levels, it can kind of play against that piece where we're trying to bring the cost down to make it affordable. So let's kind of start at the beginning. What are the products that NVIDIA has? I think a lot of people will have looked at the NVIDIA Grid K1 and K2 cards that came out 2-3 years ago now.
Yep. 3 years.
3 years. And I think a lot of people will be familiar with them in a Zen server and a Citrix Zen desktop use case. Obviously, Citrix came out a lot further before VMware with the vGPU technology, I think it was.
That's right,
And then last year we saw the vGPU technology come to vSphere and the Horizon platform as well. At the same time, you guys brought out the latest generations of cards shortly after. So maybe that's a good place for you to kick off and sort of start telling the journey after the K1, K2, where you are now in that piece.
Well, let's even refresh with the K1 and K2. So K1 and K2 were released in 2013, and they were the first graphics cards, the first GPU cards that you could put into a server and with the software that came with it, share the GPU between multiple users. So as we talked about right at the beginning, when we started with this, you could put a GPU in a virtual environment, but it was one card, one user, and that was it. So the K1, K2, the Kepler platform, that's the name of the architecture. It came out in 2013, and it really opened up the opportunity to put graphics and graphics hardware acceleration in a virtual machine. You could have up to 16 virtual machines on each GPU, which means the K2, which was the most powerful card that we produced at the time, would have up to 16 users on there, and they all got really good graphics performance. So over time, what we did was we took our vGPU technology, which is the software stack and the hardware components that are present there. The two work together in concert. What we did was we worked then with VMware to integrate that same technology stack that was in Zen Server into the VMware vSphere platform. And that happened about 18 months ago. And then when that was introduced, we were then on the process of working on the next generation at the same time. So the next generation of architecture was the Maxwell GPU. So that's the name of the current architecture. So you can probably work out where the naming convention comes from if I tell you that the next generation is called Pascal. And we'll probably hear some announcements about that later on this year. So anyway, so what we've done is we took the vGPU technology that we had built and had originally implemented it into Zen Server. Lots of work and lots of things learnt there working alongside Citrix. And they did a lot of work to implement it into their management platforms as well. And then we did the same again with VMware to take the K1 and the K2 and make it possible to deploy vGPU inside Zen Server. It's important to be aware, and sometimes people miss on this, that the actual underlying NVIDIA technology is the same on both platforms. It's just the integration into those platforms is slightly different. And Citrix just stepped up to the plate first and took it on board and ran with it. So once we got VMware on board and vGPU was in there, it was working really well, incredibly stable. I know we did about a 4-month-long early access program, and it went without a hitch, which was fantastic. Just showed how stable the product was and how solid the product was. But at the same time, we were also looking to the new generation, so the Maxwell platform. And it was at this point that we actually decided to make some changes. A big piece of that change is to actually break out the software stack from the hardware. So K1, K2, Kepler generation, they were tightly bound to the software stack, and the only features that we could develop in that software were bound to that card. We saw this as quite a limitation to ourselves, and it would also be quite a limitation to an enterprise organization. So what we chose to do is we chose to split out the software, and Grid is now considered a software platform. It is a software platform that runs on Tesla hardware. So with the new generation, which we called Grid 2.0, we're really innovative with our naming conventions at times. So Grid 2.0 is the best we could come up with. But we came up with that. So we split out the software, and it allows us to really start putting together a long-term roadmap and a strategic roadmap around technologies to go into the software stack. And again, I know you've had some insight into what's coming there. One of the big things that we've been asked around is vMotion, and the ability to have that. And we see that though we have to do a lot of that work in the software layer, and it should spread across the versions. It should not just be bound to just the Maxwell release or just the Pascal release. So it gives us the opportunity to do that and have some long-term strategic goals in software, regardless of the hardware that sits underneath it. But then at the same time as doing this, we timed it so that we would make the change with the new Maxwell card releases. So the new cards and the new software were released in September of last year, so September 2015. And we have two different versions of the card now. We have the Tesla M60, which is 2 GPUs, and on there, that each GPU has 8 GB of graphics memory, or frame buffer, as you'll often hear me referring to it. So those 2 GPUs, 8 GB of frame buffer. That is twice the capacity that the previous generation K2 had. So it had 2 GPUs, but only 4 GB of graphics memory each. So we've gone from 8 GB on a card to 16 GB on a card. As a result, it's given us the opportunity to double the number of users that we can put on a card or on a GPU even, yet still give the same level of performance and the same level of user experience. So what we've done by moving up the hardware is actually doubled the density available on the hardware straight away. You get that immediately by moving to the new card. We've also introduced some new technologies, or expanded on some technologies that are in there. So even if you put a single user on that GPU, they're getting anywhere between 1.5 to 2 times boost in performance as an individual based on the previous generation's card, yet all within the same power envelope. So one of the things that a lot of the engineering goes into with the GPU architecture is actually keeping the power consumption down. Instead of just pouring electricity in and using hundreds of watts per hour or thousands of watts per hour, we aim to keep that down and try and keep everything within a similar power envelope all along. So this is one of some of the things that go into developing the board. One area that we'd kind of not been prepared for when we released K1 and K2 was the demand in the blade space. So those blade chassis and blade deployments are quite substantial, and particularly for those of us who spend a long time around VDI, it's a very popular platform for desktop virtualization. So in the first release, we kind of missed the opportunity to work there. And that's why we introduced the M6 card. Okay. So the M6, in parallel with the M60, they're effectively the same GPU, but the M6 has just a single GPU on it. And it's what we call an MXM form factor. So this is slightly larger than the Decker playing cards. Obviously a lot thinner, but it's slightly larger than a Decker playing cards. It will take up to 100 watts in power. So we can put a single GPU on there, 8 GB of graphics memory, and it will fit inside a blade. So if you take somebody like HP or Cisco, they are now able to ship a blade with a GPU inside it, which only takes up 1 rack slot. I think previously we'd had a couple of organizations had kind of got around the problem, a couple of the OEMs had got around the problem by having mezzanine cards that would sit alongside the blade. But that meant you lost a blade slot. So you might be able to put a K2 in there next to the blade, but you lose that slot in your blade chassis. So it's there. Now with the M6, what you get is the ability to have effectively the same performance as in a single K2, but inside that blade. So you're not giving up any of your blade enclosure just for GPUs. Yet the M60 with 8 GB of the M6 with 8 GB of graphics memory on there will support the same number of users as the K2 would have done, and give them the same user experience. In fact, in many cases, better user experience, even when it's fully loaded to 16. So those are some of the changes that we made. Now, the grid software is licensed on a perpetual basis. So it's kind of one of those things that if you don't want to worry about maintaining it and updating it, and that's the version you want, then once you've bought the license, you're good to go. But as you would expect with anyone that's developing software today, we provide the option to have a subscription model around that, so that once you've bought your perpetual license, you pay a subscription fee and you're guaranteed updates and releases as they come out in the future. The flexibility that this whole platform provides now means that when a new generation of hardware is released, you can simply replace the underlying hardware with new hardware. So you take out your tester M60s and M6s and you replace it with the next generation, and the software across the top continues to work and support that. I think probably the last big change that we made as well was to introduce dedicated support. So in the past, any support that we had, because we simply provided hardware, you would go to the OEM. So if you bought your K1 or K2 through Cisco or Dell or HP or Lenovo, then any support issues you had, you went to them and they would then route it through and come through to NVIDIA. So it adds a layer of complexity. So what we opted again to do with Grid is, because we're focusing at enterprise deployments and organizations that want support and direct support with the vendor, we introduced a support model as well. So now with the Grid 2.0 platform, you get direct support with NVIDIA instead of having to go through the OEM for that whole software stack.
And I think that's kind of concluded on a number of problems, challenges that we're facing in VDI. The first one is user experience, and user experience is king. At the end of the day, if we're moving platform, if we're changing platform, we need to be improving users' user experience. And if we think we're able to do that without the support of people like NVIDIA to be delivering the user experience, and ultimately what the user looks, feels and touches, that's the first stumbling block we have. But secondly, it all comes down to building a business case and cost, density, having the right support, having a platform that is flexible and extensible, is critical to doing that. So, by bringing user experience together with the right cost and business case, that's where VDI ultimately is going to be a success inside one of our customers' businesses.
Absolutely. The number of times that I've worked on projects in the past that have been derailed because the user experience hasn't achieved the level that those people that are actually sitting in front of a desk and doing the work to what they expect are numerous, countless almost. And the number of times and effort that has had to come in to rescue projects like that, because maybe we'd made assumptions in planning and maybe we'd used used lots of tools to determine how many users we can get into an environment, but not actually looked at how the users are working and what it is that they're doing. Because users will always tell us one thing and do another. They never actually give us a true indication of what are they really doing. And user experience is absolutely critical. Like I say, I've been around desktop virtualization for a long time and application virtualization and remoting. And for many years, there were certain applications that we just said, you can't deploy those. You're not going to deploy or virtualize those because they don't work. They won't work in a virtual environment. You know, the CAD applications, the media and entertainment applications, the image manipulation and management applications. So lots of things like that we'd always said, no, you can't. You just can't do that. Leave those 10, 20, 30% of your employees on their laptops and workstations and put everybody else, all of the knowledge workers on there that don't need access to those kinds of applications, we'll put those in virtualization. So now we're in the situation where we can take users which have really high graphical demands, so those CAD workers, geoscientists, medical practitioners that want to look at radiology data, for example, and put them in a virtual environment. Because we can put a GPU in there and we know that we can drive the applications in the way that they're expecting them to see that. But in addition to that, part of the Grid platform introduces a set of SDKs which the protocol vendors could take advantage of. And so Citrix have taken advantage of this, and VMware have, and also NICE with their DCV software, which is now part of Amazon, they took advantage of the SDKs as well. So they can pull information out from the GPU more quickly than waiting for it to be drawn on a screen and then scraping it, capturing it. So it accelerates the user experience there, or what's delivered to the user. So with these high-end graphically demanding users, we can now put them in a virtual environment, give them their applications and allow them to interact with them in the same way as they would on the desktop. So they now can get all of the benefits of VDI that for years we've been going and selling and really telling everybody about why you should be on VDI and what the benefit is. And now all these high-end graphically demanding users can get it. But
I think that's the main thing, and I heard that at Grid Days with some of the customer stories are around there. It's not the fact, fantastic, they're now on VDI, we can get rid of their PCs. It's, wait a minute, this is actually enabling our business. The people that are doing the CAD architecture diagrams or blueprints for a helicopter, I think on one of the case studies with Bell Helicopters is that they're able to take those architecture diagrams, the frameworks out to the customer, and they're sitting there with a laptop or an iPad CAD, able to show the customer in real time what that looks like, make changes on screen. Whereas previously they had to print them, take out, go with a marker pen, draw all over the diagram as to what was changing, go back, CAD engineer would then put it back in, go back and get it signed off. So you're able to shorten that sales cycle in their example, but in medical, the how long it takes for diagnosis, the ability to go from one place to another, interacting. I mean, I presume that some of these CAD files get to many, I don't know, gigabytes, terabytes in size.
Yeah, gigabytes, certainly.
And from that perspective, you try shipping that across the world and collaborating with someone across the world on some of these more advanced building diagrams and automotive platforms, or even sort of GIS when you're looking at the bottom of a seabed or something like that. If we're able to centralize that into a single data set but allow the people to come to that data, it has a massive effect to a business. So you're able to build that business case so much easier. Absolutely.
And that's it. It's the story of centralizing data and centralizing workflows is something that, again, we've talked about in VDI, in desktop virtualization for a long time. It's bring everything together because all the information is held centrally. But then when you've got a lot of distributed engineers and people working on these CAD designs and CAD models, exactly as you said, that data, you can't centralize it because it's so big. It takes all day to copy it across from here to, copy it from the UK to India. And then at the end of the day, they've got to copy it all back. And something that, the effect of that is that, as you said, it has a negative effect on collaboration, because if 3 or 4 people are working on a file or a model or a building, and one person makes a change that might affect another, then you could potentially lose 1 or 2 days' work as a result of that, because somebody's made a change and they've not saved it back, because it takes 4 hours to save it back into the environment from where they are. So they do it at the end of the day, or they might even do it at the end of the week. I'll work on it for a whole week and then I'll save it. Whereas when you're virtualizing, when all your data is effectively in the same place as your desktop is in the data center, and you hit save and it maybe takes 60 seconds to save your file, maybe even 3 minutes to save your file. But people are more inclined to do that because it saves their work and it saves their own work than if they were when it takes 20 minutes, an hour, 2 hours, half a day. The knock-on effect of that to a business is that they don't lose on rework time. They don't lose on somebody else having to catch up and make changes because of somebody else's collaborative work. People are seeing changes practically in real time, and information is caught up. And it also means that they get to use a lot of the other technologies that the CAD providers and the CAD developers produce around managing those files and managing that information. Because they are as aware as everybody else is that managing data, checking it in, checking it out, keeping control over who's accessed what is hugely important, but it requires a centralization of data. And to centralize the data, you've got to make it easy to access that data. So lots of knock-on effects there. That yes, all of the benefits of, again, I say all of the benefits that VDI will bring, but now for those demanding workloads and those demanding users. So yeah, it's when people start to look at how much money, and I know that we've had one construction company look at, architecture and construction company look at how much cost is saved just in the amount of time saved collaboratively. It's phenomenal. It could make or break the difference between being profitable on a project or not.
Sure.
So it's hugely valuable. But these are the things that we often overlook because we're just talking about technology and about solutions, and we're trying to get the cheapest experience for the user. It's not necessarily about the cheapest solution. It's about what's valuable to the business.
And it's getting that package together, isn't it? It's getting the user experience, the business needs, and then getting it together in a business case. So actually it's something we can sign off and allow our users to work with.
Yeah, and it's important, I think, for us to be aware that a lot of, again, for those of us that have come from a desktop virtualization background, these are industries that often we've shied away from. So it's a new set of industries and a new set of verticals that we have to learn about and understand what are their challenges.
Yeah.
What is it that they're trying to achieve, and then how can we help them benefit from that? So yeah, it's certainly an interesting learning curve getting into this technology.
Definitely. definitely. And one of the things at Grid Days was we were learning about the kind of methodology that you should use when working with these customers, about understanding those workloads. And for me, the kind of suck it and see methodology, the need to actually try these workloads inside the environment and understand how they will work for you is never so important. When we can look at the high level statistics and go, oh, I think this is going to work, this user's got this card in there at the moment, so they're going to need this. Realistically, users probably aren't making 100% usage of the NVIDIA cards that they've got in their workstations at the moment, and we need to have the correct tools to be able to monitor that as a starting point, but then ultimately get the users onto a desktop, see what actually happens on the virtual desktop, try the different profiles, try the different user densities out, and get that right mix to be able to build the business case, but ultimately give that user what they need.
That's right. And understanding how the GPU interacts and works in that environment is hugely important. And you touch on a really good point, is that a lot of people have a GPU in their desktop which is rarely stressed. It sits there, and probably for 90% of the time it's not breaking a sweat. It may be running at 10, 20, 30%. But the reason it's in there, and the reason that they've got such a high spec board, is for that 10% times. So those jobs that maybe they do once a week, maybe they do once a fortnight, where it puts a real huge demanding load on there, and the thing will spike through the roof and it will sit there for a few seconds and then drop down. Or it may be that, you know, they're doing some of these things, and we've noted, and this is something we've picked up on in the past, is that lots of monitoring tools, when we're monitoring on 1 second intervals, miss the spikes that go for 30 milliseconds and then they're down and they're gone. So the spike has been and gone before the monitoring tool has picked it up. And this is the thing about GPUs, is something changes, something moves, it's done very, very quickly, and then we're on to the next thing. And it's why we built the GPU virtualization to be around time sharing and scheduling, instead of taking the GPU cores and carving them up to dedicated users, because that way we know that this workload is very, very spiky. It's very rare for somebody to put, except maybe in gaming and VR gaming, VR and rendering will certainly put a consistent load on there. But those aren't the kind of things that we're going to put in a virtual desktop anyway, certainly not today. So we know that this is a very spiky workload. Somebody will make a change in a model, they'll zoom, they'll pan, they'll add textures, whatever it may be, and it will spike for a particular period of time. Or they might run a render very quickly to see what it looks like, and then they're on to the next thing. Because the workload spikes, it means that we can share that time more efficiently across multiple users. So as a result, within that tight little power envelope that we've developed, you not only get a lot of performance, but actually as a user you probably get more GPU than we've initially allocated to you. So when we put 4 users on the GPU, if nobody else is using the GPU, that if there's 1 user on there and everybody else is if there are 4 users on there, 1 user's doing something, the rest are idle, we'll give that user the whole GPU until fair sharing kicks in and everybody else gets using it. And that, because the workload is spiky, you can do that and get better density than you maybe might have done by just looking at the card and going, that's this spec and therefore I need half a K2 or a quarter of an M60.
Yeah, and I think this brings us to a good point, is as to what the users are using today. And when we're talking about NVIDIA graphics, are we only talking about those top users using, I don't know, AutoCAD and ArcGIS and CATIA? When realistically, whenever you're out there buying a PC, buying a laptop, it's got a graphics card in it. Yet for some reason we think when we get to VDI, no graphics card is a perfectly acceptable scenario. I mean, you've got NVIDIA on your shirt. I know what your response is going to be, but how do people consider that? Do we really need a graphics card everywhere? Well, obviously it's very nice for it to do, but there are workloads that we do on a daily basis, things like, I don't know, PowerPoint, that actually does have quite a large graphics requirement, that all we're doing is putting that processing power onto the CPU, which isn't best placed to deliver that workload, which stops us being able to get the density out of the server, which ultimately costs us more money because we have more servers, where we could be working using the correct profiles, using the correct technologies to deliver that fantastic user experience with the graphical power they need behind them for a better overall package.
Yeah, I think you've hit on a really pertinent point there, is that every PC, every laptop, every desktop, even every cell phone or tablet that you go and buy has GPU technology in there to do the graphics. And now we go and try and do that in a CPU when we virtualize. And then we wonder why users complain about a poor user experience. Or we give them a desktop user experience from the early 90s instead of the desktop experience that they expect today. And it is increasingly the case that applications are being written with hardware acceleration assumed to be present. So a lot of applications just expect it to be there. If you run Outlook and just look and see how much GPU it will consume, it's sitting there consuming GPU resource to give you that visual experience that you expect to see. PowerPoint transitions and all those kind of things, they will look for and use hardware acceleration if it's there. Your browser, probably the most used application on most people's desktops, if we're honest, is the browser. We put huge amounts of information into corporate intranets and into external wikis and web pages and all this kind of thing. And we use it to pull information together. In fact, a lot of applications that are used even at the task worker level today are written in the browser.
Sure.
Because it makes them highly portable, and it's there. But many of them assume that there's hardware acceleration there. So the visuals that are written in there, it tries to do with hardware acceleration with the GPU. If that's not present, then it will either switch that functionality off or it will drop it down and try and run it on the CPU. And as a result, we lose on scalability and density and all sorts of things there. Certain applications, so take WebGL, for example, some of the things that are anything that's written in WebGL, it has a minimum level of technology requirement to be able to run forward. And we have seen situations where an application simply won't start, a web application simply won't start because it doesn't have hardware acceleration available to it. Tiny little bit, a bit of shared GPU in there, smallest virtual GPU possible, application starts, application runs, user can get on and carry on working. And in a couple of situations we've seen, that's been the difference between being able to go to virtualization or not, because that was a critical app to stop there. So yeah, the browsers and the operating system itself. So even before we get to any applications, the new way that the new interfaces for Windows 8 and Windows 10, they're all written with DirectX in mind. They leverage DirectX. So they're looking again to benefit from hardware acceleration. And I think quite a few people have already started looking at things like Windows 10, virtualizing Windows 10, and seeing how much more load that will put on the CPU to give that experience versus Windows 7, where we knew that Aero expected a lot and made a lot of demands on the user, on the resources, but it's certainly not as big as the new modern interface in Windows 10. So we have to think about all of those things as well and take those in mind. So even just the basic underlying operating system with the core applications of Office and the browser will benefit from a GPU. Is it the right thing for everybody? That's got to be a business decision as to how important is the user experience and what applications are there. But the technology is there. Every user will benefit from it, but is there a business justification and a business value behind that benefit there?
And I think from my perspective as the man without NVIDIA on my shirt, it is about finding those users, about those use cases. Clearly, unfortunately, as we stand here today, if we try to do it on every single use case, it's probably going to make VDI unaffordable for a lot of users.
Yes. Yeah.
However, for those other users, it is that difference between making it a solution that's okay, maybe workable, but that solution that is really delivering that user experience, delivering an experience that allows them to be more productive inside the environment, use the applications that they do want to be able to use. So for me, it really does come down to understanding the users, understanding the use cases, understanding the technologies available, and the price ranges of those technologies, so you can get the right technology into the right place for the user.
That's right. I was just thinking, one of the, actually, when we're looking at price range, density, scalability as well, is that we've got technologies from Citrix XenApp and VMware's RDSH technologies solution as well. So both of those also support GPU acceleration. So we can put grid underneath those and deliver the Office experience as a shared hosted solution. Now that's a really good option for high density delivery and delivering that user experience to a large proportion of users, whereas desktop virtualization, because of the way that vGPU is limited to 16 users per physical GPU today, maybe is not as scalable for that use case. But like you say, look at all the technologies that are around there, and you'll probably find an option which is a good choice.
And I think the other thing then that we were able to touch upon, and I'm putting you on the spot a little bit here, is obviously VMware have been doing a number of updates recently. That we've got Horizon 7 just around the corner. They've been working on their own protocol. We've got Blast Extreme due to be coming out shortly. Now, typically, if we wanted to offload the protocol processing in a VMware solution in the past, that was obviously being handled by Teradata and PC over IP, and it still can be moving forward. But we had the challenge about whether we were going to put more grid cards into a server, or whether we were going to put Teradata, I think it was Apex cards, into a server to offload. Are we offloading graphics processing, or are we offloading the protocol that is being used to remotely display that? As I understand it now, obviously with Blast Extreme, they've moved that part of it away from the relationship with Teradata, whilst that is still one concentration that they've got. And the other is now they've been looking at more industry standard protocols that they're able to use, or certainly engines that they're able to use to enhance it. How does NVIDIA Grid play a part in offloading that Blast Extreme protocol, and where's the fit for NVIDIA with that?
Sure. Okay, so Blast Extreme is an extension of the earlier Blast protocol, which was used, HTML access and also for the Linux workloads. My understanding is that they're going to continue with PC over IP. This was just the alternative for those platforms that didn't support PC over IP. But there was also a lot of pressure to, as you say, come up with some more standards-based solutions. So Blast Extreme is based on H.264. So it's pretty much a standard and an incredibly common compression mechanism now. It's the same one that Citrix use. It's the same one that Nice DCV uses, and you'll find it all over the place. Even Netflix and streaming your movies down, it's H.264, H.265. So what they have the opportunity to do, and what they've done with Blast Extreme, is they've taken the fact that on each and every NVIDIA GPU from Kepler up onwards, we've included hardware encoding capability for H.264. And we also provide an SDK so that you can build that into, and build the use of that into your own technologies. Within Grid, we've taken it further and added a little bit more special sauce in there around protocol developments and things like that. And that's what we've taken from the learnings that we talked about earlier on in the gaming side of things, is what can we do there. So with Blast Extreme, what they're doing now is, as that runs, instead of it taking the information from the GPU as it's created its frame, it's created the image that's drawn on the screen, and then passing it up to the CPU, where the CPU draws it and then renders it and then sends it out across the network. We keep everything in the GPU. So we render the frame, we create the scene, we create the image, we pass it to the encoder encodes it, and it gets sent out as compressed H.264 down across the wire. Of course, VMware have got further technologies around there as well, and I am simplifying it a little bit, but essentially we've taken the load off the CPU for encoding and compression and kept it into the GPU in hardware which is built just to do that. So the advantage is that you just free up immediately. You free up the CPU that was previously being used for encoding. And taking examples, Esri ArcGIS, for example, delivering that to between 30 and 60 frames per second down to the user. By taking the encoding off the CPU and putting it on the GPU, we've seen an increase in, at 1080p resolution, 1920 by 1080p resolution, we've seen an increase in around 20% users because we've freed up CPU. You've got more CPU to play with, so you can put more users on as a result. If that's 2, 3, 4, 5, 10, whatever density you're getting, extra users for actually having not invested any more money because you've already got the grid cards in there to drive the application.
Yep.
That's a huge benefit because your density and your scalability starts to get affected. The other thing that we've discovered, which we'd kind of anticipated but didn't know how much it was going to impact, was that as resolutions increase, the demand on the encoder increases. Mm-hmm. So therefore, if you increase resolution, you would put increased load on the CPU. Mm-hmm. But again, the hardware in the GPU is designed to do this all day, all night, and carry on doing it. So actually, we've seen better improvements as users move to higher resolutions. We were seeing over 20%. I think the numbers specifically were 18% at 1920 by 1080, and then moving up to 2560 by 1600, which is effectively double the number of pixels. We're getting into the realms of 22, 23%. So, and people are looking at 4K now and considering 4K. So being able to keep that off the CPU, free that up for users. Now, whether that's more users on the server or whether it's users getting more CPU and getting a better experience all told, again, that's a business decision around that particular project. But that's what VMware are doing. The other thing that came out of that, and I know that you saw the demonstration and how this was actually tested, was how much it takes out of the round trip time. Yep. When what we refer to as click to photon. So from when you click the mouse button to when you see a photon appear on the screen or your eyes detect it, how quickly can we get that down there? This is something that, again, on the GeForce side in gaming, it's an obsession. Mm-hmm. People click to photon is an obsession in that organization. And so we've brought those learnings over, built them and developed them into the SDK, and this is what VMware have been taking advantage of. And we've seen that we've been able to take 50 milliseconds out of the round trip time compared to PC over IP. Mm-hmm. Just because we're not taking anything out of the CPU, out of the GPU, passing it to the CPU, then passing it back somewhere else. Yep. We're keeping the pipeline simple. We're taking memory copies and memory transfers out. Simplify the whole process, take one extra step or two extra steps out of the chain, keep it all on the same bit of silicon, and we take time out of it. And if you think 50 milliseconds in a remoted protocol, yep. it's a big impact. 50 milliseconds is about 3 frames, if you think about it in that context. Somewhere between 2 and 3 frames, depending on what frame rate you're running. So it can be quite effective and impactful on the interactivity of things, as well as taking the load off. So there's a number of benefits that have been gained by VMware and Blast Extreme, which by the time this video goes out, I would hope has been released and generally available. Mm-hmm. So there's lots of benefits that have been gained by having the ability to use GPU encode in there. And yes, it's a feature that is only available on the NVIDIA Grid platform.
Fantastic. And for me, it's all starting to come together. When it comes to VDI workloads, and NVIDIA's got certainly its place to play on that. So it's an exciting time. And for me, as we started, it isn't just what you're doing in the VDI space. You're getting involved in lots of aspects of people's lives. So thank you ever so much, Jason. I think there's an exciting conference coming from NVIDIA soon. Is it the GPU Tech Conference taking place?
That's right. So GPU Technology Conference, or we refer to it as GTC quite often, so you'll hear us talking about that. That is the 4th to the 7th of April in Santa Clara. Fantastic. That's where our CEO will be out on stage making announcements. Last year we had self-driving cars on stage and all sorts of other things. And it's the opportunity to come along and see not just what's going on in grid and in virtualization, but what NVIDIA is doing across the board and across all these other different verticals as well, and all these other sectors, I should say, as well. It's always really interesting, eye-opener, and you'll come away with a headache and a blown mind, I can guarantee it.
And I think for the first time you're also doing a European one in October, I think it is, isn't it? In Amsterdam.
So we are doing a European one. We've brought it forward and it's in September. Okay. So it'll be the last week of September. It'll be in Amsterdam, 2 days, and a more condensed version of what we'll be running in the US. But it does make it easier for some of us to get there and get to Amsterdam than it does to go to Santa Clara for a week.
Definitely. Well, thank you ever so much for your time, Jason. I hope the people that watch the video are fans of interest. If you want any more information, feel free to reach out to me on @virtualizereal on Twitter or on the various website addresses. Or Jason, are you on Twitter?
I certainly am, so you can find me at Jason_Southern, and yeah, feel free to ask questions and hit me up there.
Brilliant. Thank you very much.
You're welcome, Barry. Thank you.